I'll let you switch gears to data.
All right, good. Well, this was fun because I got to talk a bit about what my day job is with being an IT director, and then my passion projects, which are more in the data science arena. So as a quick prelude before we jump in, on the data science side, what that really means is it's someone who is leveraging a statistical approach. So it's partly its process and methodology, and then a set of tools to help analyze a sea of information. And that's a very broad term intentionally, but a sea of information to find insights. And that can be everything from recommending what movie or song to listen to next. So if you think of Netflix, Amazon, Spotify, et cetera, all are using those. It can be text and speech recognition, like what powers your Alexa devices. It can be numeric information or text that you're saying, I'd like to find out more about who's buying our product. So there's an infinite set of potential use cases for data scientists, and it's a fun field. As I said, it's what I did early on in my career before it was called that, and I still dabble in it with side projects and things like that. I think you've already seen this. I didn't know if it was going to be broken up, so let's skip on ahead. So what is a data scientist? So as I said, it's helping to solve business problems first and foremost. It really, while it has a lot of sort of academic elements to it, and particularly some of the techniques we use, it's very, very business focused. And it uses tools and algorithms, I'll talk a bit about both, to solve these problems. And when I talk about wide array of use cases, so to give you a little taste of what I've done, we build a system for higher education, for colleges and universities, for their scholars to search all of the public archives of things like the New York Times or scholarly journals dating back to the 1800s. We digitized all those, we loaded it into a search engine, and then did analytics on top of that so they could say what kind of trends, like pick a trend like inflation is a popular one these days. What's been the vernacular around inflation from the 1800s to now, and being able to visualize that. That's an example. We put sensors on 18-wheelers, on semi-trucks, to find out when they might break down, and we analyze that data to predict this truck needs to go in for service, it needs to have its brakes done, et cetera, to avoid any expensive damage or an accident on the road. So two very, very different use cases, everything in between, from helping to discover drugs more quickly for things like cancer and HIV, and the sky's the limit on this. But the approach is generally the same for all of those. It starts with identifying what you're trying to solve, what's the problem you're trying to solve. It could be increasing sales of a particular product. It could be improving the quality or preventing something from happening. There's all different kinds of use cases. It leverages the scientific method, meaning you still come in and you say, well, I think it might be this. I have a hunch, I have a suspicion, I want to test this. And so it gives you a direction to analyze, and you prove whether or not that suspicion is correct. It is a lot of data cleaning and preparation. So you have to like data, and you have to like manipulating data and getting it into formats that are useful, because most of the time the systems we're working with are messy and disjointed and nothing matches up. And so it's a fair amount of called data massaging. You're sort of getting it ready to be analyzed. And then it's the fun part. So you leverage these things called machine learning algorithms that really are, it's modeled to look at information and think about it in a certain way. So it might be, if you're looking at car insurance buyers, you might want to segment those based on common characteristics. So you say, these people like to buy their insurance this way and hold it for a long time. And you're sort of looking at all of these different socioeconomic information and creating a group. That's one type of algorithm. And a lot of it is training or tweaking the settings and such to get the results that you need by leveraging some of these algorithms. I will confess, I am not a statistician. I didn't do great at statistics. I don't love it. I know how to use it and apply it, which is what's important. But you do not need to, especially today with what's available sort of off the shelf from providers. you don't have to be a superstar math person or a statistician to be able to use these tools to good effect. And you still do need to understand some general concepts, but again, it's not my strongest suit, but I can still be very effective at it. The last few, data visualization, which is presenting the results in some kind of digestible way, and that can be everything from a chart, a line graph, a list, to something much more sophisticated like we did a project where we did a virtual reality word cloud, which meant you could sort of put on your headset and the words that were close to you were associated to something, and then you could sort of swipe them away or step through the space and look at other clusters of information. So it was exploratory research. That's more cutting edge. And then there's this concept called it's data storytelling. And what I mean by that is increasingly it's important for the information to tell the story you want to get across. And there's actually a cross-disciplinary field here called data journalism, which is if you're a journalist looking to, let's say, report on the impacts of climate change or policing in the US and those kind of topics, to actually visualize that and show data in a way that gets your point across is really cool, really magical. Like it helps people understand information in different ways. So that's the tactics. And what a data scientist does is they do these kind of projects a lot of the time. So it's most of the time you're sort of engaged by the business to tackle certain issues, problems. You might work on one really large one for a year, or you could do 6 or 7 in a month, just depending on the scope and size and complexity. But the other big piece is education. So this is still a very new concept for many, many people in business. And a lot of your role as a data scientist is simply educating people why it's important, what it's like, how to trust the data. So it's a lot of explanation and advocacy. And that is a cultural shift. It takes a lot of time and a lot of energy. So you need to have the fortitude to stick to it. But it's really, I mean, it's been neat for me to see with the organizations that have worked, how much they have matured in the way that they think about problems, and then seeing that translate to real progress in the work they're doing. Okay. So as I mentioned, I would say the typical is you'll have a couple of initiatives. It's almost the same as project managers, which we talk about separately, but no fewer than 2 because you want that variety, and no more than 4 or 5 because cognitively we as humans break down when we got to deal with anything more than half a dozen. So that tends to be the sweet spot. This one is not this is not an always on role. It tends to be project driven, generally normal hours. Most of these things are not driving some deadline that has to be met or some crisis that needs to be addressed right now. They tend to be more project oriented. But you could have surges where there's some deadline that needs to be met sooner, and you might shift and work in the evening. I used to love this because when I was younger, pre-kids, I would stay up late, work till 2 in the morning, love it, have cups of coffee, it was great. Then I had kids, and then I switched, and I would wake up at 5 a.m. and do a lot of my coding and work before the kids woke up and things got crazy. So it does accommodate some of those off hours for people that just have that style preference. I talked about data preparation. A lot of what's changed for me and for everyone over the last 20 years is that what we used to write on our own and have to sort of hand build every single time, you can now take off the shelf and use from one of the big providers like a Microsoft or Amazon or Google. And that's a huge, huge difference because it used to take us, some of the systems we built, it literally took us years and millions of dollars to build a certain application, where a few years ago I built something similar in 2 months for $30,000 or something like that. I mean, it was just night and day difference. And so that ability to leverage pre-existing knowledge and then just the sheer compute power that we have now means that this field is getting really, really exciting, and it's starting to blend with artificial intelligence and machine learning and some of those more advanced fields. As I mentioned with the IT director, you're not immune to needing to talk to people. I think especially in this role, there's certainly the heads down work where you're really sort of focused and doing a lot of really deep thinking. But then as important, if not more important, is the sharing of that information and working with others. So there's a lot of business communication, both on progress, challenges you're running into, and results, but also teamwork, because you need the data, which means talking to finance or HR to get the data from them. And then you need to work with the development team to bring things into production use. You need to work with your financial analysts that are doing projections. There's all sorts of different elements. And I would say the data scientist actually probably works cross-disciplinary with more teams than just about anyone else in an IT organization, with maybe the exception of like a project manager or a strategy person. All right. So the career path is similar in many ways to what other IT roles are. With the exception that there tends to be more of a tilt toward either mathematics and statistics or information management, computer science certainly, but it's more tilted toward that data element, obviously. And there are now degrees and programs in this field where there were not 10, 15 years ago. But if you hear terms like business analytics, information sciences, those types of things, anything around data and information or analytics tend to be relevant. And it doesn't have to be this way, but the best data scientists that I've seen have two attributes in common. One is that they do have strong technical chops, or they've developed strong technical experience around either software development, so they come at it from the coding perspective, or they'll come at it from database management, so managing these data repositories, understanding how to query data, get information back. That tends to be sort of the early journey for data scientists. And then definitely project-based work. And then also it really helps. I'm a huge proponent of having people that are cross-disciplinary. And I mentioned Xavier earlier, when we were talking to the students, one of them was a dual major in computer science and marketing, which I loved. Another one was journalism and computer science. So you see this kind of like this mashup or this blending of passions. And those individuals really, really do well, because it is, I didn't talk about this before, the hardest challenge in an IT department is the communication. It's the translation. And I joke that my career has basically been as a highly paid translator, because I'm helping to take business speak and turn it into computer speak and vice versa, because so few people can sit comfortably in the middle, that if you have that background and a dual role and interest in it, it can be hugely, hugely valuable from a career path. Okay. And again, the caveat is no one path is right, and everything is topsy-turvy with IT. They will hire anybody anywhere, which is awesome for all of you coming in to the market. But yes, it is. It is insane right now. It is insane. Okay. A couple of other, I touched on most of these already, but I'll just hit on a couple of quick ones. I talked about core skills before as vitally important. It does really help to have an understanding of domain knowledge. So if you're working with scientists, understanding a little bit about what they do, or if you're working with a car manufacturer, understand a little bit about the engineering. You don't have to be an expert, but having that vernacular, that language to converse with them is really, really helpful. It is really important, and I should have added this on the other one too, this notion of business cases and return on investment, meaning, and we're bad at this in IT. We sort of just say, well, we'll throw money at the problem. Let's just buy everybody X, or we'll buy this new software package. And without really saying, does it make sense to you? Are we going to get the value out of it? So understanding how to build a defensible business case to say, yes, this is an investment worth making. That's a really key skill, and it's fairly rare in the IT space. On the technical side, I mentioned data. So data modeling, and if you've ever heard of SQL or SQL, it's basically a sort of programming language to get data out of a database. Python and R are the most popular data science tools right now. understanding some of the algorithms, and then definitely data visualization. You could make a whole career simply out of using something like Microsoft's Power BI or a product called Tableau to take data and present it in interesting ways. So I said, solid foundation, but you don't have to be an expert. I cannot stress this enough. Similar to how I mentioned getting started in IT in general, if you're going to be a developer or a database person or a business analyst, whatever, the experiences that you can get early on by being hands-on are pivotal. And data science in particular, it's really easy to go out to, let's say there's a site called data.gov, and you can go out and download a bunch of statistics from the Census Bureau and from other parts of the government that are now freely available. There's lots of sites where you can get your hands on data in an interesting problem and experiment. And that's a great way to test out. And then also you can talk about it when you're having that first interview. You can say, oh yeah, I did, that was one of my first roles. I started as a software developer in a startup, and my real world experience was actually developing some really bad Excel software for a chemistry lab that I happened to intern in. So that was my foot in the door. It doesn't need to be fancy, and it can be informal, and that's okay. It's experience. All right. Well, good. So that's everything that makes sense to cover here. I would just say, much like with an IT director, the shift that I've seen in this space is the business acumen and the interest, the business acumen and being able to help solve business problems is becoming more and more important in these kind of roles, because the techniques are becoming more widespread, data is becoming easier to get to, systems are easier to work with, so that some of those barriers to entry are lessening now. And that means that people that can help solve the business problem itself is even more important. All right, so Patty, I'll see what kind of questions the audience has for this one.
All right, thank you. This is really informative. This is a new field. I loved learning all about it. So we got one question coming in. Have you always been enamored by data and statistics? If so, do you feel close to data that could affect issues and problems that you're passionate about?
Yeah, that's great. I think so. If I think back early enough, I would say I was initially enamored, like as a kid, sadly, as like a elementary and middle schooler, I loved coding. So that's actually how I sort of got into technology, was I just loved building things. I played video games probably too much. And so I was like, I could build those too. But I think by the time I hit high school, it really dawned on me, and particularly when I got into school, that information was the more interesting side of that. And for instance, I had a background in biochemistry. The first company that I worked in, we built three-dimensional modeling and analysis of chemical compounds, which was just about the coolest job I ever had. It was so awesome. So like that combining of the programming with the data was what I got excited about. Yeah, and then in terms of like, I think that especially now with so much of we're dealing with some really, really critical, serious, existential kind of concerns in the world. And there are too many of them, sadly, to count. Data and using data to help build trust and commonality. I think there is a lot there to be done over the next 20 years because I am sort of a moderating, the truth lies in the middle kind of thing, and data can be a window into that helps to tone down the rhetoric and tone down the frustration and try to have more of a conversation. So yeah, I do. And I think what is exciting is there's so many what are called, if you've heard the term citizen data scientists, but it's basically hobbyists, and I sort of count myself as that now because I'm too far out of the field as a professional, grabbing data sets that are available and going and trying to solve things and just building awareness. And there's so much of that now, and that's only the tip of the iceberg. Yeah.
And what is your favorite data science website?
Oh, so there are a couple. KD Nuggets, which is Knowledge Discovery Nuggets, is a website that's been around since I started in this field, and it's just as clunky and terrible now as it was then, but it's updated regularly, chock full of information. It has lots of good tools that you can go and download, as well as data sets and things like that. So KD Nuggets, and then I'm a big Python developer, so there's a library called sklearn or scikit-learn that is brilliant because it's great documentation. It also lets you help learn some of these techniques, and you can ingest this data set and then just start running a bunch of algorithms on it. And it's very easy, very intuitive, relatively speaking, compared to some other things out there. Yeah.
That's great. Couple more questions. It seems like there's a lot of pathways to becoming a data scientist. How does a student know which one to pursue?
That is okay. Yeah, it's there's a phrase called the paradox of choice. If you have too many options, then it becomes paralyzing and you're stuck. And I would say I had no master plan when I started. And it's the beauty of being older and having hindsight is you can weave together this elaborate story about how everything was preordained and intentional. No, I mean, half the time I just like, that looks fun. I'll go. So I know that's not a great answer, but no, I mean, it is something where if you again go back to trying and sort of tasting different applications of this and experiences, then that will help form an opinion for you. It's different for every person. And it's not, there's no one right answer. So I'll give you two examples. The first is a colleague of mine he's Canadian, moved down here, he's PhD statistics, works wonders around algorithms, and his expertise is helping to build these kind of systems. He's not, all those kinds of things I said about being great with people and teamwork, not so much, but he's really, really good at building software and these algorithms. And so that's what he's found his passion to be. Contrast that with, I did a lot of work with a data journalism group out of Seattle, and they're creatives. They're passionate about designing things and telling stories. And then they discovered that data was a powerful way to do that. So they sort of picked up some of those skills along the way, but they're first and foremost a creative group. And so it's sort of where your passion lies. I'd say those would be, to me, those are sort of the three areas. It's the expert, it's following your passion and leveraging data as part of that. And then the third, I would say, is for those that are sort of more business oriented, whether it's marketing or finance tend to be the most common ones. If you really enjoy that, get a sort of an analytics background to couple with that, and you'll be a rock star, because so few of those exist.
Okay, great, thank you.
Yeah.
So we have another question. There's usually a single introduction course to computer science in grades 9th or 10th. What would you recommend a school to be teaching? Should they focus on Python, Java, JavaScript? I know you mentioned Python a couple of times during this presentation. Is that one you think is the biggest thing for the buck for a student, for a school to teach, or do you have different preferences?
That's a good question. The areas that I don't think a program could go wrong in is, Python is one of those for sure, because of some of the data and just general principles that you learn coding in Python. Another would be SQL and data management. I've seen that actually even in high school courses around how to get data out of systems and such. But, the other side of that is JavaScript, particularly. I'd say JavaScript more so than anything else, and some of the libraries around JavaScript is the hottest code, the hottest language in user developed sort of application development, both the user experience, the interface, as well as increasingly the server side, because of some libraries like Node.js. So I'd say between Python and JavaScript, you can't go wrong. The important thing, and I now can write in, you sort of become polylingual. I can probably write in about 5 or 6 different languages right now, because once you learn the concepts of one and then apply it to a second one, going to the third, fourth, and fifth are not nearly as difficult. And so I definitely encourage developing at least two. And it doesn't need to be at the same time, certainly, and you can take different courses, but yes, that bilingual is important.
Okay, great. Well, do we have any other questions? There's some chats going on. They're answering each other back and forth. I think we covered all the questions. If not, I'll give people another minute here.
Sure. And while waiting for the questions, there is a lot of confusion now around what is AI. And so you'll hear AI used a lot. And a lot of times what they're really talking about are these algorithms and machine learning. So it's sort of become a marketing kind of thing. They'll throw AI on everything to make it sound cool and more expensive. But it's all the same stuff. It's the kinds of things a data scientist or a machine learning developer would do. It's a matter of scale. We have more data and more compute power and better algorithms. So we're able to do more than we could 20 years ago.
Thank you. I think that's pretty much all of our questions. I know we had a couple of questions about internships, and SOCHE will help with the internship side. We do have connections from the business side to help students find opportunities. So whenever we have those opportunities, we'll let you all know. And we're continuously working with our industry partners like you to provide opportunities for the students. But Matt, we definitely thank you today for your time. It's been very informative. I know the students who are here today definitely learned a lot, and then the students who will be listening to this at a later date will also be learning a lot from you. So thank you for your time. We appreciate it. And for everybody who attended today, thank you. Next week, we will be talking about talking to a database administrator and a network engineer. You all have a great week, and we'll see you later. Thank you. Goodbye.